This video is going to show a quick and easy way of how to set up systems of linear equations so that you can solve them by graphing. On the first equation, on the first problem, a system of linear equations, they need to be in y equals format. Since this system, which is two equations with two variables, is already in y equals format, we can go ahead and graph them. So what we do is we take both equations and type them into our y equals. So we go to y equals. Notice that the plot 1, plot 2, and plot 3 are not highlighted. This is very important. Going to y1, I'm going to type in my first equation into y1. This is a negative, not a minus, negative 3x, which is located here, plus 4. I go down to my second equation and I type in this next one, which is 3x minus, not a negative, minus 2. Once I have them both into the y equals, I press graph so I can see the intersection. These two lines should cross to make a solution. As you can see, the graphs, the two lines do cross, and it's inside the first quadrant. What that means is that our x and our y should both be positive. So to find this intersection, we press the buttons second, trace, and we want 5 for the intersect. So I'm going to press 5. Now it comes back to the graph and we have this blinking cursor. So I'm going to move this blinking cursor to this intersection. So I'm going to press left or right to get to that intersection. I'm going to press right so I can get to it. As long as I'm close to it, I should be able to do this fairly easily. So once we're in the general location of it, I'm going to press enter 3 times. So enter, enter, enter. Once you press enter the third time, it should pop up to say intersection, which is exactly what we want because that's what we were looking for, the intersection. So the intersection is at 1 and positive 1. We knew that it was in quadrant 1, so they both should be positive. This is a coordinate, so we must write our solution as a coordinate. Our coordinate is parentheses 1, 1. This is our solution. On the second problem, you can see that they are not in the y equals format. This is where I'm going to show you how to do a quick and easy way to put it into y equals format so you can graph it quickly. You can solve them like you've always have, put it into slope-intercept form, y equals mx plus b, by subtracting, adding, dividing, and actually simplifying everything. What I'm going to show you is how to put in your calculator without having to worry about simplifying the values. Obviously, if you are asked to solve it and actually write out the correct equation, this would not be the method you would want to use. But if you are just using your calculator, this is perfectly acceptable. The first thing I'm going to do, I notice that my x and y are on the same side. I know that I have to move my x to the other side. So I'm going to take my x, I'm going to circle it. I know that I have to move this to the other side. When I move it to the other side of an equation, I will have to subtract it. So I'm going to rewrite the equation, what I have right now. I have my negative y equals. This is the most crucial part. You must put parentheses. I keep my 3 as it was, but then my x, when I moved it, turned into a negative, so I'm going to put minus x. Then I'm going to close my parentheses because that was the end of that section. Now, to get y by itself, if you notice that there is a negative attached to this, I'm actually going to circle this and say this is what I have to divide by. So I'm going to divide by this negative, which is really a negative 1. Now I have everything away from the y, so I'm going to rewrite the equation so I know exactly what to type into my calculator. I'm going to have a y by itself, y equals, I have parentheses, 3 minus x, close parentheses, and then divided by negative 1. This is actually going to be my first equation. I'm going to do the same thing with the second one. So I can see that I have an x and a y on the same side. So I'm going to circle this 7x, and I know I have to move it to the other side. I rewrite what I have. I have the negative y equals. And again, the most crucial part is that parentheses. We have parentheses. We still have a negative 3. And then we have a minus 7x because it moved to the other side, minus 7x. And I close that parentheses. Then I still have something attached to the y, so I'm going to circle that. And I know that's what I have to divide by. Whatever's attached to the y is what I divide by. So I'm going to divide by that negative, which is a negative 1. I'm going to rewrite this so that I have my y completely alone. So I have a positive y now is equal to the parentheses, negative 3 minus 7x, close the parentheses, divided by a negative 1. Now that I have the two equations, I can type them into my calculator. So I'm going to go back to my calculator. I'm going to go back to my y equals. So I'm going to clear both of these out from earlier. Go back up to y1. I'm going to retype this in exactly as it says. We have parentheses, 3 minus x, close parentheses, divided by a negative 1. I'm going to go down. I'm going to put parentheses, negative 3 minus 7x, close parentheses, divided by a negative 1. I'm going to press graph so I can see if they intersect. There's the first line. There's the second line. And they do intersect, and it looks like they're in the third quadrant, so we should have a negative x and a negative y. Now let's go find the intersection. We're going to press the button second, trace. We're going to press number 5 for intersect. So 5. Again, it brings us back to the screen. We're going to, your cursor could have been up here or down here. It doesn't really matter where the cursor is right now, just as long as you can get it to the intersection. So I have to press left to get to that intersection, just a little bit. Okay. As soon as I'm close to the intersection, I'm going to press enter 3 times. So enter, enter, enter. It says intersection. That means I know I'm done. And I do have a negative 1 and a negative 4. And in the third quadrant, I know that my solution should have been a negative and a negative. So our solution is at negative 1, negative 4. Again, this is written as a coordinate. It's parentheses, negative 1, comma, negative 4. Because this is the coordinate that these two equations will intersect at, which is the solution to the system of equations. I'm going to do the same thing on this one. I have an x and a y on the same side, so I know that I need to move my x. So I'm going to circle my 4x, the entire x, and I have to move it to the other side. This time I'm going to have a positive y. I'm going to write in black. Positive y equals parentheses. I have a 2. I'm going to subtract the 4x, so minus 4x, close parentheses. There is nothing attached to the y, therefore I don't have to divide by anything. So my orange equation I'm going to write over here that I'm going to type into the calculator is y equals parentheses 2 minus 4x, close parentheses. On the second one, I have an x and y together, so I do need to move my x. So again, I'm going to have I have a negative y equals parentheses, I have a 3. Then I have to move my x, so I have to subtract the x, close parentheses. Now this time there is something attached to the y, so I'm going to say I have to divide by that. I have to divide by negative 1. So again, my equation will be y equals parentheses 3 minus x, close parentheses, divided by negative 1. Once I have these two equations, I can go to my calculator. So I go back to my y equals right up here, and I clear out both of these. And again, do you see how none of the plots are highlighted? That's what's really important. You need to make sure none of the plots are highlighted. I am going to make a mistake on this one right here. I'm going to type in something that shouldn't be there so you can see one of the errors that might pop up. It says 2 minus 4x in parentheses, so parentheses 2. I should do minus, but this time I'm going to press negative just to show you something. Negative 4x, close parentheses. I'm going to come down. I'm going to put parentheses 3. This time I will put the minus x, close parentheses, divided by a negative 1. Do you notice the difference between the two signs right here? See how this one is slightly smaller than this one? This one is a negative, not a minus sign. When I press graph, it goes to error syntax. That generally means that your minuses and negatives are mixed up. So if I go to, it actually is saying which one is wrong. That should have been a minus sign instead of a negative. So I don't have to press delete or clear. I can actually just, as it's blinking on the negative, I can come down here and just press the minus sign, and it will replace that with a minus sign. Now these two look the same. Now I'm going to press graph again, and this time it should graph correctly. We have our intersection. It's in the fourth quadrant. So we're going to go find the intersection. We're going to press second, trace. We're going to press 5. We're going to get to that intersection by pressing right. I'm going to press right a couple times until I get close to the intersection. We're going to press enter 3 times. Enter, enter, enter. It says intersection. You don't stop until it says intersection. The intersection is at 1, -2. So our solution, again, is a coordinate. So it's parentheses 1, comma, -2, close parentheses. That's our solution to this one. Now, on number 4, you can actually see that these are already set up in y = format, so you can type them into your calculator as they are. I'm going to move on to another one. I'm going to switch pages. I'm going to look at number 6 and 7 real quick. Number 6 is already in the y = format on this first one, and it's just y = -5. That's actually a horizontal line down at -5. This second one is not in the correct format, and I see an x and a y together, so I do know I have to move the x, so same thing we did earlier. I have a positive 4y equal to parentheses a -20, and then a minus 5x because I moved the 5x, close parentheses. I do have a 4 connected to the y, so that's what we have to divide by. I have to divide this by a positive 4. So our two equations in orange, I'm going to have y equals -5 for the first one, and then y equals parentheses -20 minus 5x, close parentheses, divided by 4. Now we can go back to our calculator. I'm going to go to y equals, I'm going to clear both of these out. I'm going to type in -5 again. This is a negative, not a minus. -5. And the second one is parentheses -20 minus 5x, close parentheses, divided by 4. I'm going to press graph. There's the horizontal line. There's your second line. So again, we're going to find the intersection, and you can see that it's on the y-axis. So you know it should be 0, something, and we can probably see that that's going to be a 0. Looks like -5. And if we look, it says y = -5, so that's a good bet. So we're going to go to second, trace, 5. We're going to press, we're already actually at it, so I'm going to press enter 3 times. Enter, enter, enter. My intersection does in fact say 0, -5. Now, you might have a number that looks something like this. I'm just going to write something here. It might be a -1, e -16. This is scientific notation. E -16 really means times 10 to the -16th. What that is that you move the decimal of -1, it should be a decimal there. You have to move the decimal 16 places to the left. So if we move it to the left so many times, this really represents 0. And you can see that this is in fact a 0. So even though your number looks really weird, it actually does still represent 0. Okay, so our solution on this one is in fact 0, -5. 0, -5. In parentheses. Remember, it's a coordinate, so you do have to have it in parentheses with a comma. Number 7, I really want to focus on because it has a -7x. I want to make sure you understand what to do here. Yes, they are still together, so we have to move this -7x. So I will have a positive 2y equal to parentheses 18, and since this is negative, and when we move it, it will become a positive 7x, close parentheses. Then, yes, there is something attached to the y, so we will divide by that 2. We will have y equals parentheses 18 plus 7x, close parentheses, divided by 2. On the second part of that, we have a 6x and a y together, so we know we have to move this 6x. we will have a positive 6y equal to parentheses 0 minus 6x, close parentheses. We do have something that's still attached to the y, so we know we're going to divide by that 6. So we'll end up having y equals parentheses 0 minus 6x, close parentheses, divided by 6. And yes, of course, you could simplify this ahead of time. On this one, we would have had 18 divided by 2, which is 9, but then we would have had 7 divided by 2, which actually needs to stay as a fraction. So I'm trying to help you eliminate having so many fractions. On this one, 0 minus 6x would just be negative 6x, and then we'd have divide by 6. That'd just be negative 6 divided by 6, which is just negative 1. So if you had that, that's still perfectly fine. Okay. We would still graph these. So I'm going to do this a little quicker. So clear, parentheses 18 plus 7x, close parentheses, divided by 2. And then we're going to have parentheses 0 minus 6x, close parentheses, divided by 6. Press graph. We have our two solutions. So we're going to press second trace 5. And you do need to wait until the graphs completely load before you press second trace 5. I'm going to get to, my cursor is up here. I'm going to move to the left. I'm going to press enter, enter, enter. The intersection is at negative 2, comma, positive 2. Negative 2, comma, positive 2. I would like to move down to number 9 and number 10. Okay, so number 8, you're going to do, it's still the same setup. We're still going to do the same thing. We're going to set these up. I'm going to move this negative 3x to the other side, and I know I'm going to move the negative x to the other side. So I'm going to have a positive 3y equals parentheses 4 plus 3x, close parentheses. And on this one, I'm going to have a y equals to a parentheses 3 plus x. On this first equation, I still have a 3 connected to the y, so I know I'm going to divide by 3. On the second one, I don't have anything connected, so this will be my equation. So I will have y equals parentheses 4 plus 3x, parentheses divided by 3. And the second one will be y equals parentheses 3 plus x. Go ahead and graph these. Clear, parentheses 4 plus 3x, close parentheses, divided by 3. And then parentheses 3 plus x. I'm going to graph this. Here's our first equation, first line. Second line. As you can see, these lines look like they're never going to touch, and these are considered parallel lines. So that means if they never touch, they will have no solution. So this actually, the solution to this one is no solution. No solution. It's because they are parallel lines, and we can actually see that. And we have parallel lines. We can actually look back at the equations and show that they are in fact parallel. Parallel lines are lines that look like this, where they will never intersect. They are supposed to have the same slope, but a different y-intercept. Because if they have the same y-intercept, then it would be the same line, and that is not parallel. So to look at the slope, it's attached to our x. Okay, so 3x divided by 3 is a positive just x, and this is a positive x. Those have the same slope. Then our y-intercept is our constant, still divided by 3, so it's 4 divided by 3. But then this one has a 3. So this 4/3 and 3, they have different y-intercepts. So they are in fact parallel. So this is in fact no solution. On the last one, I'm going to do this quickly again. I know I have to move my 3x. And I know I'm going to have to move my negative 6x because it's on the same side as the y. So I have a positive 4y equals parentheses 7 minus 3x, close parentheses. I'm going to have a negative 8y equals to parentheses negative 14 plus 6x, close parentheses. I have a 4 attached to this y, so now I'm going to divide by 4. I have a negative 8 attached to this y, so I'm going to divide by negative 8. I'm going to rewrite the equations. I have a y equal to parentheses 7 minus 3x, close parentheses, divided by 4. And a y equals parentheses negative 14 plus 6x, close parentheses, divided by negative 8. So I'm going to graph these. Clear. Parentheses 7 minus 3x, close parentheses, divided by 4. and then parentheses negative 14 plus 6x, close parentheses, divided by a negative 8. We're going to press graph. There's the first line. And you can still see it was loading, but it looks like there's no other line on here, so it's potentially that this could be the same line. So let's look at the equations. If it's the same line, it should have the same slope and the same y-intercept. So let's look at our slope. We have a negative 3x divided by 4, and then we have a positive 6x divided by negative 8. Well, this becomes a negative 3/4, and 6 divided by negative 8 is also a negative 3/4. So far they do have the same slope. Now I have to check the y-intercept. If the y-intercept is the same, it is also the exact same line. So we have a 7 divided by 4, and then we have a negative 14 divided by negative 8. This will also become a positive 7 over a positive 4. So these are, in fact, the same lines. So how many times will it cross? They will cross forever, so that means infinitely many. We do not say all solutions because this is not a solution. Anywhere over here is not a solution. These are not solutions. We say infinitely many because they will cross forever, but not every single number is a solution. So our answer is infinitely many solutions. And if we were given the equations, we can see that these are the exact same equations. So these are the same line, because they are the exact same equations. If we look at the equations, exact same equations. They have the same slope and the same y-intercept. Again, this was just a quick way of how to set up your equations so that you can actually put them into your y equals into your calculator. This is to solve systems of equations by graphing.